Trilobites are an iconic group of extinct marine animals. They first appeared around 521 million years ago and survived for an astonishing 270 million years until they became extinct in the late Permian. These ancient creatures were among the earliest and most successful arthropods, a phylum that today includes crustaceans, insects, arachnids, and other groups. With over 17,000 known species, Tribolites are remarkably diverse, from bottom dwellers that fed on plankton to larger species that lived in the open sea. Trilobites, as their name suggests, had 3 lobes: the left, axial, and right pleural lobes. Their body can also be divided into 3 parts: the cephalon, the thorax, and the pygidium. They had a calcified exoskeleton with jointed appendages beneath it, allowing for movement, feeding, and sensory perception. The eyes of trilobites have been the focus of many paleontological studies. Initially, all species had a type of eye called the holocral eye, which could hold up to several thousand lenses. During the early Ordovician, trilobites, along with many other marine animals, diversified and expanded their habitats from the sea bottom to the open waters. In this time, a new type of eye evolved within the subclass Phacopina. It's called the schizocral eye, and it had larger lenses that were separated from each other, providing a wider field of view compared to the holocral eye. Their improved vision likely helped them to escape predators or catch their own prey more effectively. At the end of the Ordovician, the climate became cooler and the oceans were partly covered with ice. Trilobites adapted to these harsh conditions by migrating to the deep seas, where they developed reduced eyesight and in some cases even blindness. Like their modern arthropod relatives, they grew by molting their exoskeletons. As they grew, they transitioned through various larval stages, each molt bringing them closer to maturity. The molting state must have been a vulnerable position to be in, and it's likely that trilobites were seeking shelter to protect themselves. Paleontologists found clusters of similar-sized trilobites and think that this indicates that molting might have taken place collectively, possibly within sheltered areas. Some clusters have been found in a linear pattern, suggesting that trilobites sought shelters in tunnels, while other linear clusters indicate that they might migrated together in what looks like a parade. Trilobites also evolved intriguing defense mechanisms. Some species could enroll their bodies into a tight ball for protection, a trait that also can be observed in modern-day pill millipedes, such as this huge one that I found in the jungle of Borneo. It is important to note that although both types of organisms are arthropods, they are not direct descendants, and the trait evolved independently. The existence of trilobites stretches from the early Cambrian to the end of the Permian. Thriving in the oceans for an impressive span of 270 million years, this immense time span, which is difficult to fully grasp, encompasses changes in continental positions, shifts in ecological compositions, and the rise and fall of many types of animals. The legacy of trilobites is preserved in fossils and continues to teach us about resilience, adaptability, and the wonders of life on Earth.